Shared values algorithm question. Let's imagine that we're to create a function called shared values, where we're given two parameters, both of which being strings. And for this function, our goal or purpose is to try and find every character that is shared between these two strings and count the number of instances that this character is shared. Now, what do I mean by the number of instances that these are shared? Because that's a little bit of a mouthful and quite convoluted, right? Well, if we look at example 1, the first string only has one A, whereas the second string has 2, right? And so if we're going to be making a pair where we say it's truly shared between these two elements, then we can say, well, these two are a pair, but what happens to this one, right? Because this one's now eliminated for string 1. String 2, not so much, right? There's no other A that it can go to, and so it's just kind of a free floater. And so when we go to the output then, it should just be A equals 1, where its value for the key should be 1, despite the second string having 2 occurrences of it. And the same is true of the B, where there's one B here, but there are 2 here. And so these two become paired, but what happens to this guy? Well, nothing. He doesn't have a pairing. And so the result then, or whatever output this function will give us, is just one instance of B and one instance of A, which is shared between these two strings. And this pattern repeats itself when we look at example 2, where, well, the first string has 2 B's, 1, 2, right? But the second string only has 1. And so these two get matched, but this lonely guy has no pairing. And this process, well, will repeat with whatever 2 strings that you're given, right? And this will output something along the lines of, there's one pairing for B, there's one pairing for R, despite librarian having 2 of them, and there are 2 instances for A between these 2 strings. So luckily for these 2, they're not, none of them are lonely in the case of A, right? And so how do we implement this function then? Well, what we can do is create a dictionary, right? Where we iterate over one of these 2 strings, it doesn't really matter which one, and we say, well, for every character that we've looked at, hasn't it shown up yet? If it hasn't, then add it into this dictionary, right? And so for the first iteration, well, we go from having checked nothing, hence there being an empty dictionary, to having checked A. And we say, well, A isn't in this dictionary yet, and so we can add it in there. And because now we've seen at least one A, we can pair it with a value 1, just saying, hey, we've seen this value, right? And then we move on to the next character. And now we've seen that, and we've seen C, and so on and so forth until we get to F. But ABBA is probably a little bit more interesting, where we have 2 characters, but we'll get to that in a minute. And so if this string was slightly different, because we wanted to look at what repeating characters looks like, right? Let's say there's another A here, and another one, and another one, right? Well, for every instance that we see it, it would go, well, we're going to want to increment this value. So 1 plus 1, and then we want to increment it again. So let's say a plus another 1, and so on and so forth until this equals 4 in accordance with the number of occurrences, right? But if we're going to want to compare this string with this string, then maybe instead of just recording one value, maybe instead we can make it a key value pair with an array, where the array contains two values, one being the number of occurrences where A appears in the first string, and the second being the number of occurrences where we've seen it in the second string. And we're going to initialize it to 0 because, well, we haven't looked at the second string yet. So how would we know, right? And so if we go through this iteration with this kind of logic, well, we can just say B is going to be 0, and C is going to be 1 and 0 because, well, this is the first occurrence that we've seen it in the first array. And we've seen 0 occurrences of this because we haven't looked at the second array yet. And so on and so forth until we get to A, again, over here, right? And once we get to that point, we go, well, we've already seen it, and if we've seen it, that means that this number here should be in accordance with the number of instances that we've come across that character in set string, right? And so since we've got into this point again, well, then in the same vein as here, we would increment it, right? And do that again, and again, until there are no more instances where A appears in the string. And once we've done that, what essentially winds up happening is this dictionary will have every single character that appears in the first string. And it'll also have the number of occurrences that character appeared. Because, well, with a for loop, it's going to iterate over every single character. Unless you wind up making some kind of if statement that makes it skip or terminate early, right? And so now that we've iterated over this first string, what do we do after that, right? Well, our goal was to compare these two strings, so why not iterate over this one, right? And so we look at ABBA and we say, well, the first iteration is A, and because we're in the second string, we're going to be looking over here. And so right now we have 4 occurrences in the first string because it went 1, 2, 3, 4, right? And now that we've come across one instance of A in the second string, it now gets initialized to 1. And the same thing for B, where B occurs once in the first string, and so we put 1. And now we finally come across B in the second string, and so we initialize that one to 1 as well. And then we come across it a second time, and so it winds up incrementing. And same with A, where it goes 4 and 2, right? Or it might be a bit more clear if I go with equals, 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 and equals. I'm sorry for the poor writing, but now that we've compared these two, we're going to want to return out a string that kind of looks like A, B, right? And so how do we do that? Well, what we can do is currently this dictionary has every single character in this first string, and we don't really want that, right? Because F has 0 occurrences where it's shared between these two. It doesn't ever show up in the second string. And so instead of that, let's make a new dictionary, right? And this new dictionary, we're just gonna base it off of the two values in here, where we say, okay, let's take the exact same key, iterate over every single element in this dictionary, like all of the dot items, and then take the minimum value of the values of the key and store that as a new key, or a new value, sorry. And so how does that look? Because again, this wording is a little bit convoluted, right? Well, let's take this A as an example. Right now in the dot items, it's going to iterate over itself until it gets to the A, right, as a key. And it's going to take the values that's stored in here. So there's 4 and 2. And what we're doing here is we're saying, well, let's take the minimum value between these two, right? And whichever one is smaller, that's going to be assigned to A in this new dictionary. And once we've done that, well, so long as we're ignoring the zeros, and then what will eventually happen is we'll get every single key where they're shared, but because we're taking the minimum value, it's going to be the exact number that can be paired between these two. And by that point, this algorithm is basically finished, right? We can just return this dictionary, not that one, this dictionary, and then if we want to print the results, it'll give us, or it should give us, what's ever in here. And yeah, that's how you solve the shared values problem, loosely speaking. Thanks for listening.